Okay, so this problem is about gravitational force, gravitational field strength. So let's see here. The figure here shows a skydiver before the parachute open. And for now, you can see that they have two arrows, an air resistance upward. That's a force that being like exerted by the air on the skydiver, and the strength of this force is 760 Newton. And then he also undergo another force that pulls downward, and this force is the reason that pulling him downward towards the route. A. The skydiver has a mass of 84 kilograms. They asked to state the name of the force label as Q. So we can see that this one is the force. Okay, so this one itself is a force, and that should be the gravity, right? The gravitational force. Or we can also call it as the weight. And that's the force that pulling the skydiver down to the route. So here when you mention this is a field strength, it is not, it's a force, okay? So what is a gravitational field strength? Then we can see it's mentioned here in the next question. That's usually symbolized a little g, and the unit is also different. If we have the force should be measured in Newton, like this one, the air resistance is a force itself, and measured in Newton. This one is measured in Newton per kilogram. So we can see that they have two different units. So they are two different identity, two different quantity in physics. Here they ask us to calculate the size of the force that labeled as Q. So yes, this is a tip, right? We can always like trace back the formula based on the units given. So we can see that, okay, we have some Newton here, and I see that you have the note here as a F. That's the unit for the force over kilogram, or like divided by kilogram. So basically you can derive the equations again, like G equals F divided by mass, right? Great. So you got the equation already. So let's see if this is the equation, and now the F here is actually the Q, right? That label Q is in this specific problem. So then if we have, let me write again here on the side, G equals to Q over M. So if we want to solve for Q, right? So Q is being divided by M, then we got the G. So the Q should be like the product if we got the M times with the G, right? Or if we do slowly like this, if we multiply both sides with M, right, like this, then we can see that M and M like this cancel out. So what left here is the Q, and here is the mg. So I hope that this kind of math makes sense to you. So we basically have the mass, which is given like 84. So just plug in the values, 84 kilograms times with the 10 newtons per kilogram. So now you can see again the unit here. Let's do the unit here, kilograms times Newton divided by kilograms. So basically we can also cancel out kilogram with kilogram, right? So what left for now is just Newton. Then everything makes sense. So if 84 times with 10, then we should have the answers a 840 newtons, okay? So that's not 8.4. Next here, the air resistance force, okay, you see here they mentioned this is a force. At one point during the skydiver journey is 760 Newton. Okay, so this is the moment that have been illustrated here in this figure. Use the answer in this question to calculate the acceleration of the skydiver when the air resistance force is this much. So how can we find the acceleration? And yes, this is the units given. Okay, so in order to solve this question, we need to recall the theory of the Newton's second law. Do you remember what?
10 seconds, starting now.
Do you know what is the Newton's second law is about? The Newton's second law is that the acceleration caused to the object is resulted from the F net. It means that the total force act on the object of a mass m, and the acceleration will inversely proportional to the mass. The bigger the mass, the smaller the acceleration. So just imagine if you have really a big elephant, a really big elephant. I'm trying to draw a really big elephant here, where it's drawn here and it's smiling. It also have a little tail. So imagine an elephant should have its weight measured in tons, right? Many tons. So it's pretty heavy. If you try to push it here, like this is you, and if you try to push it, it's not easy to push it at all, right? Because if you apply an F to the elephant, but its mass is so big, then the resultant vector A is really small, It means that the bigger the mass, if you apply a specific amount of F, the acceleration is not that significant. Okay? What about the other way? What if the elephant pushes? Okay? So what if we here and then the elephant try to push us? Then we can see that if, for example, if the elephant will just apply the same amount of the force, but because our little mass is too little, right? Then with its strength, it can give us a really big acceleration. So basically, the relationship with the acceleration and the mass is that is inversely proportional to the mass. This is the symbol for inversely proportional to the mass. What does it mean? It means that if you got the mass increased by twice, then the acceleration will decrease by half, okay, with the same number of times, right, of the values, like the multiple. So here, using this one, that's how we can calculate the A. So now we can see the mass is given already, 84. What about the F net? Do we know the F net yet? So F net here, we need to know how to add the vectors. So vector is what? Vector is a quantity with direction. Is a quantity with direction. If you have a quantity without direction, how is this called? It is called a scalar quantity, okay? A scalar, this is the adjective to describe it. A scalar quantity is a quantity without direction. But vector is with direction. What does it mean by direction? Well, you can see here air resistance push it up and the gravitational force pull it down. So basically it tells us about in which direction that the two things are interacting with each other. So here, imagine if something push you up 760 Newton and you also have something pull you down with 840 Newton. You can see that I try to draw this one longer because I can see that the amount of force on this way downward is much more compared to the upward. Okay, so just like when you play the tug of war, what could happen here? What the result in here? It's very easy for us to see, right? In the end, the one that going downward here will be the winner, right? And how much is the difference? That will be 140 newtons minus this much, right? This is the difference. Because this force is stronger than this force, and the amount of stronger is can you do some math for me, please? Yes. Is that 80? Yes, 80 newtons. Okay, so that's the difference, and actually this is the F net. Okay, this one here. No, maybe let me make the color to be the green color, or maybe the blue color because it's the extra one downward. This is the F net. Okay, this one is the 80 Newton. The difference, the amount, how the downward force is winning over the upward force. Okay, that's the difference. So the F net here turns out to be acceleration equals to the 740 newtons minus 760 newton divided by the mass, which is 84 newton. So I think from here we can use the calculator, right? So let's double check with the calculator. 840 minus 760 divided by 84. I got like 20 per 21. If we round it up, it's about 0. Not this value, 0.75. Okay, I will just take the two significant figure because this one have two significant figure, this one also have two, so we should be good with like the fewest number of significant figure for division, which is just like 95. So what is the unit now? Okay, in the equation from the Newton's second law, we can rewrite as F equals to ma. So because we're in the SI system, the unit, the international unit, when force is measured in Newton and when when mass is measured in kilogram, then the acceleration, which is the rate of change. If you remember the definitions of the acceleration, the rate of change in velocity over time. Okay, so then you can see if you got the rate, the velocity, which is meter per second, right? Then you divide it by time again. That should be meter per second square. So you can see it here. It also give you the unit already. So as long as you have the force measured in Newton in the SI system, the mass measured in Newton in kilogram, then automatically the result will be measured in meter per second square because we have all the unit in the SI system already. This is the SI system of the unit. So here this is meter per second square. Yeah, so it means that if you have the mass given in a kilogram, like in grams or in tons, then you have to convert it into kilogram in order to get the acceleration measured in meter per second square. Okay, so this is the unit, meter per second square. So this is the final answer. Okay.